right, so now we're going to talk about application of three-dimensional geometry. So you would think this would be story problems, but not necessarily. We're looking at three-dimensional figures kind of in a different way. Now, this can be tough. I personally have an issue with looking at three-dimensional figures, but you know, it is what it is. So we have to try to find some way to deal with it. So in this example here, well, in the figure that's given to you here, we've got a rectangle, and if you look at some connections through the middle of the rectangle, so you can see there's a segment from D to C, a segment from D to B, and a segment from A to C. Those are not lines that you would normally think about, but if you can concentrate just on the CDB, you can see over to the side that's a right triangle. And how do I know that it's a right triangle? Well, right here, okay, I know that that's a right angle, like that entire space is a right angle in that figure. So I can kind of just carry that over. Same thing, I can look at a diagonal CA there on the outside, and I can look at that as another right triangle. A lot of this is about right triangles, so it's a matter of just trying to visualize where that is, and like I said, I know it's not always easy. So the first two examples here are like the first two questions in your homework. Use the diagram below to find the length of AG to the nearest tenth if AC is 4.5, DG is 6.2, and FG is 4.1. Okay, well let's start putting some of this stuff in here. So DG is 6.2, so 6.2. FG is 4.1, and AC is 4.5. Now this is a cuboid, so we can transfer numbers over however they're going to be more helpful to us. This is also 4.5, this is also 4.1, and I can do lots more, but that's all we need to worry about for right now. I want to find the length of AG. Well, that's in my picture for me. Now, if we can look at this and visualize that, find a right triangle, basically. Okay, so that's like a hypotenuse. If we can look at this right here, think of that as the base of a triangle, okay, and so it's a diagonal BG, and then look at this as the side of our triangle, and I'm going to redraw that over here now. So this is A, B, and G. This was 4.1. I don't know this, and I'm trying to find this. Okay, well, back to the drawing board. All right, so look back over here. I'm trying to find this, so obviously there's not going to be a way directly that I can find that in this triangle, but look at that diagonal line down here. That diagonal line down here is the hypotenuse of another right triangle. Okay, so think about the bottom. Okay, the bottom is a rectangle, and if I cut that in half, there's my right triangle. Okay. So this is 4.5, this is 6.2, we'll just call that X. Okay, so I'm going to find that segment. So that's going to be 4.5 squared plus 6.2 squared is equal to X squared. I end up with X being the square root of 58.69. Now, don't actually find that. We want to keep that exact. Okay, well that goes right there. So now we can do the Pythagorean theorem and find the side that I want. So that's going to be 16.81. When I square this, I get 58.69 is m squared. So I end up with m is the square root of 75.5. Now go ahead and put that in 8.69 meters. Okay. All right. Now we have, think about slicing kind of through the diagonal of our figure here. So we're looking at plane AEGD. So just a reminder, when you name a plane, you only need 3 letters in the plane to be able to name it. But in this case, since it's a rectangle, they went ahead and threw that 4th one in. So AEGD, so that's the slanted gray one there. And then plane BDGH. BDGH, that's the bottom. And we'll just say this is the slanted. All right, so AD is 13 and AB is 5. And we want to find the angle between the plane. Okay, so think about we get a protractor in here and we measure. You're going to measure an angle from a horizontal side, or from a from a horizontal side. So this is the angle that we're looking at here. Okay. So I've got a right triangle right there. That one's pretty easy to see. So right here is the triangle that we're dealing with, 13 and 5. I want to find that angle. So that's my opposite and my hypotenuse. So the sine of theta would be 5/13. So we do an inverse sine here. And that gives me 22.6 degrees. Okay, pretty straightforward. Okay. Now, just a little note down here at the bottom, use the solutions to help. Your book has pretty good solutions. A lot of these, they have drawn extra pictures to help. And then once you figure out what you're trying to find, draw that picture. So once you know, for example, up here, that you're trying to find this diagonal, because that may not be drawn. Sorry, you can't see that. Here, once you know you're trying to find that diagonal, go ahead and redraw a picture, because that diagonal is probably not going to be drawn in your picture. They might just say find AG, and then you have to visualize that that's that diagonal. Okay, so we have a room here is in the shape of a cuboid, and its floor measures such and such. Calculate the length of AC and AG, and then calculate the angle that AG makes with the floor. Now, here's the thing. In IB, they like to have part A, part B, part C kind of questions. So a lot of times, by the time you get to part C, you will have used part A and part B. Now, sometimes if you can't figure out how to get part A and part B, go ahead and make something up just so you can get to that part C. Okay. So first of all, let's look at AC here. So AC is going to be this right here. So essentially, we've already done that kind of computation in one of the other ones there. AC. We've got a right triangle here, kind of trying to draw it in the same position that it is in my picture, and I want to find x. Okay, so x squared is equal to 7.2 squared, 9.6 squared. Turns out that's equal to 144, which is nice for me because now that comes out to be exact. So AC is 12 meters. All right, now we want to find, and let's switch colors here. Now we want to find AG. Okay, so AG is going to come through the middle here. So again, this is going to be very much like what we just did. Lost my train of thought here. Okay, so now we have 3.5 over there is also 3.5 right here. So now for AG, we have a triangle 3.5. 12, and I'm looking for x. So x squared is equal to 12 squared plus 3.5 squared. Sorry, my decimal kind of ran into my 5 there. X squared is 156.25. And also very nice for me, x turns out to be exactly 12.5. So AG is 12.5. Now, find the angle that AG makes with the floor. Okay, so that's going to be this angle right here, which is this angle right here, and we've already got that. So we'll call that theta. Theta is going to be tangent of theta is opposite over adjacent. So inverse tangent of 3.5 over 12 gives me theta is 16.3. Okay. Alrighty, one more example here, and then I just want to kind of talk you through a couple of things you're going to see in your book. We have a right triangle shown here with a square base. With a square base of side length 40. The height is also 40 now. The height, I mean, that's up through the middle. If they're giving you the slant height, they will tell you it's a slant height. Find the length of OB, then find the size of angle OBP. Okay, So length of OB, so that's this right here. Well, I think you can see this triangle here. And they are even nice enough to draw that right angle in there. They wouldn't have to do that because, again, the height is always at a right angle. Just the regular height is always at a right angle. So we've got this here, 40, don't know that, looking for this. Okay, well, how can I get this bottom? Well, you might be inclined to say that that's 20, half of 40, but that's going to a corner. So look at this here, all the way across. This is 40 right there. This is a square base, so that's a right angle. So I've got another right triangle. So we've got 40 and 40. Let's call this y. So I've got 40 squared plus 40 squared is equal to y squared. Y squared is 3,200. So y is the square root of 3,200. Now again, don't take that. I want to transfer that up there. Now I can do my Pythagorean theorem. So 40 squared plus the square root of 3,200 squared is equal to x squared. 1,600 plus 3,200 is x squared, and x is the square root of 4,800, which is 69.3 centimeters, and that is OB. Okay. Now, find the size of the angle. So the angle OBP would be right here. Right here. So we know that this is 69.3. Now, it would be really nice to do that exact, though. So when we set up our trig function here, we do the inverse, well, let's not do the inverse yet. Tangent of theta is equal to 40 over, well, I know what that 69.3 is. It was the square root of 4,800. So let's use that instead. And I just realized I wrote that down wrong on my paper, so I'll have to fix that. The inverse tangent of this, and you don't have to write that down. I'm just doing that kind of to remind you. Okay, let me plug this in here real quick. 40 divided by the square root of 4,800. And actually that turns out to be 30 degrees, which is kind of odd, but that's what I got there. 40 divided by, yeah, I'm going to do it one more way just to make sure, because that seems weird. Square root of 4,800. Making sure also I'm in degree mode. You don't have any reason to be in anything yet. It's 30 degrees, so there we go. Okay. All right. Now, here on the back, there were a couple problems where I kind of had an issue, and I don't plan on giving you one as difficult as this first one here, but you know, you could see something like this on the exam. So I just wanted to make sure that you knew what was going on here. So I'm not doing this problem for you. The solution is in your book, and the solution is pretty easy to follow, but I just want you to visualize what they're even asking you for. So they want you to find, for homework number 4A, find the angle between plane FBC, so that's the orange, and FCD, so that's kind of a purplish, I don't know, color there. So I've dug up my cubes and my pyramids and whatnot, and I apologize that it's kind of dirty here, but I wanted you to see what's going on. So they want you to find this, okay, this face right here. I guess it would have been nice if I had orange there, but we'll pretend that that's red. And this face here in the back, okay? So if you actually were to draw that angle out, okay, you can see these dotted lines that I have drawn, okay? That's the angle that I want to find, and I kind of gave you the side view over here. That's the angle that I want to find. Now, I have right angles drawn right here. That's just to show you that that right angle is drawn as a perpendicular, or that this dotted line is drawn as a perpendicular. You would want it drawn like that, otherwise you're not going to be getting the proper angle. So both of them are drawn that way on both sides. That angle right there, though, is not a right angle, okay? So look at the triangle, though, that is formed. And I should have done this as well. But so you've got the green dotted lines here. And then think about that. Okay, so obviously you can find that base with information that they've given you. These dotted lines right here, okay, come back over to the picture over here, okay. You can find that dotted line with information that's given to you. And then once you know those dotted lines, now you can use law of cosine. Okay, so you work on that. Again, look at the solutions. They will help you through that, but I kind of struggled with visualizing that. Now the last one, same thing. Now this is a cube as opposed to a cuboid, and the problem in your book is a cuboid, but I didn't have one of those to use as an example. Again, I had trouble just visualizing even what was going on here. So in this case, they want you to find angle AMB. Or I'm sorry, AMD. Well, first of all, they fail to tell you that M is a midpoint, so that's good to know. So in this picture right here, this is G. So M right there is my midpoint. And AMD. So A, M, and then here is D right here. Well, if you can visualize, that I drew that dotted line, this is along the edge. Okay, so obviously that's something you can find pretty easily. Right here, okay, you'll know that entire segment, so you can find that one pretty easily. And then, hey, here's my right angle, because that's happening along the corner of my shape. So we can find the hypotenuse, and then we can go from there. For 5B, this one is AMC. So A, come down here to M, C. Okay, so AC, that's no big deal. That would be something that's given to you. C to M, and then A to M. That's going to be a little bit more complicated. So I'm trying to remember actually the numbers that they've given you here. Hold on. Okay, so this one, I think you're going to have to actually look at a couple different triangles. So that's the triangle that is, kind of your right triangle. There is a right angle right here, okay? And I'm trying to find angle AMC, but I can't go quite there yet because I don't have enough information in this picture. Like I said, I know AC. I need at least one other side to be able to find an angle in this triangle. This one, I don't know how you could find that one without knowing this one. This one here, okay, notice, ooh, I've got a triangle right there. Okay, so I have to find some stuff that I don't need to find what I do need here. And then once I can get that side, then I can find my angle. Okay, so again, look at the solutions. Now these two, they don't give you pictures, and the pictures helped me out a lot. Miss Neal, actually, I'll give a shout out to her. She helped me figure out what they were looking for there as well. Okay. So this one, I've given you quite a few of these. Some of them are easier than others, so skip it if you need to. Come back to it. Definitely let me know. Tomorrow is going to be kind of a shift here, but it's the rest of this topic for IB of geometry. That's going to be doing slopes and equations for lines and solving systems. So, okay. Oh, and when you're doing the homework, please draw on the pictures. That's why I kind of gave you copies of these pages so that you wouldn't try to do it in the book. The color definitely helps.